Life on 7 continents today is very different from life on a single supercontinent 250 million years ago. Back then, strange creatures roamed the Earth, beings that were neither reptiles nor mammals, with shapes and sizes vastly different from anything we see in the modern world. This was during the Triassic period, the first era of the Mesozoic Era, a time marked by catastrophic mass extinctions that wiped out many species and paved the way for new ones, such as dinosaurs and mammals. In this episode, we'll explore the planet's environment during the supercontinent Pangaea, how life adapted to this new world, and answer the question, when did dinosaurs first appear? So, grab your drink as we journey back to the Triassic period. Mass extinctions are among the most devastating events in Earth's history. If you didn't know, our planet has endured 5 major mass extinctions, 2 of which are part of today's video. Despite there being 5, the 5th and final extinction, the asteroid strike at the end of the Cretaceous, is the most famous. While it may not have been the deadliest, it is the most thoroughly researched. The Triassic period began in the aftermath of the Permian extinction, the third and most severe extinction in Earth's history. So devastating it's often called the Great Dying. It wiped out 85 to 95% of marine vertebrates and drastically reduced terrestrial life and plant diversity. Fossils from the time between the Permian and Triassic periods show a dramatic decline in biodiversity, with only 30% of species surviving into the Triassic. There are many theories about these extinctions. Some researchers believe they occur in periodic cycles due to cosmic events like asteroid impacts. Others suggest that each extinction had unique causes, which is a perspective I lean toward, as there's no clear evidence that all extinctions were caused by celestial objects. For example, while the Cretaceous extinction has strong evidence of an asteroid, we lack conclusive proof for the others. Most theories revolve around natural changes such as continental drift, leading to earthquakes and land disruptions, shifts in ocean temperature and chemistry, or fluctuations in atmospheric oxygen and carbon dioxide levels. The start of the Triassic period was bleak, beginning with the Great Dying, the worst event in Earth's history. But this catastrophe allowed new life to adapt to the planet's harsh conditions. The Triassic marks the beginning of the Mesozoic Era, also known as the Age of Dinosaurs, which followed the end of the Paleozoic Era about 252 million years ago, and ended with the Jurassic start around 200 million years ago. During this time, the 7 continents we know today were still united as the massive supercontinent Pangaea, surrounded by a single vast ocean called Panthalassa. A continent as large as Pangaea with no internal seas would experience extreme climate seasons, scorching summers and freezing winters. However, studies of oil-bearing and sandstone fossils indicate that Pangaea's climate was relatively uniform, with no polar ice caps. Temperature differences between the equator and the poles were much smaller than today, resulting in high global temperatures and dry conditions with low oxygen levels. These were ideal conditions for reptiles to thrive. You might think dinosaurs dominated the Triassic period, since it's part of the Age of Dinosaurs, but that's not entirely true. Dinosaurs didn't appear until later in the period, and they were far from the dominant creatures at first. Instead, the Triassic was ruled by reptiles, descendants of earlier Permian creatures which spread across Pangaea. While Pangaea may seem like a vast desert filled with strange reptiles, it also featured swamps, diverse coastlines, and forests with trees like cycads and conifers. Although forests weren't as widespread as in later periods like the Jurassic, their presence added to the ecological variety. Additionally, wetlands and shorelines supported amphibians and aquatic reptiles, creating a diverse yet stark ecosystem on the supercontinent. The Triassic was a time of recovery and adaptation, a new world rising from the ashes of the Permian. It set the stage for the rise of dinosaurs, mammals, and the incredible biodiversity that would flourish in the Jurassic and Cretaceous. Now, focus with me on this next part of the video because we're about to dive into the creatures that lived during the Triassic period. Let me assure you, they were unlike anything you can imagine. In arid conditions with high temperatures and dryness across most of Pangaea, life faced extreme challenges following a catastrophic extinction. Earth needed millions of years to recover, but the Lystrosaurus managed to adapt. Despite the harsh conditions of the early Triassic, these creatures survived the extinction event and thrived. Lystrosaurus had unique characteristics that allowed them to endure. These small burrowing creatures excelled at digging tunnels to escape the harsh surface conditions. When life above ground became unbearable, they retreated underground. Emerging from the Permian period, they found themselves in an open ecological space with little competition. With vast lands and minimal biodiversity, the Lystrosaurus evolved into 6 distinct species, growing in size from 60 centimeters to 2.5 meters in length. Now, you might wonder, what were these creatures classified as? The answer isn't straightforward. Not because there isn't one, but because the Lystrosaurus belongs to a unique group. Its classification places it in the Dicynodonts therapsids. The first part of the name, Dicynodonts, means 2 dog teeth, referring to the 2 prominent tusks on either side of its jaw. Dicynodonts are an extinct group of anomalies, creatures that appear mammal-like but are actually reptiles. The second part of the name, Therapsid, refers to a group that includes ancestors and relatives of mammals. So, while the Lystrosaurus resembled mammals, it wasn't one. Instead, it was a mammal-like reptile. Its tusks might make it seem predatory, but it was actually a herbivore. During the Permian period, life was tough for the Lystrosaurus. Slow-moving and vulnerable, it faced constant threats from predators. However, in the early Triassic, survival became much easier. Predators were still developing and were relatively primitive compared to later eras. Examples include small dicynodont predators and creatures like the Proterosuchus, a type of reptile from the archosaur group. This group includes creatures like pterosaurs, dinosaurs, crocodiles, and birds. If you look closely, one species even resembles a crocodile, but with strange characteristics. It was a medium-sized quadrupedal predator that could grow up to 3.5 meters long. It found the Lystrosaurus to be the perfect prey, easy to catch and with few other options available. If it couldn't hunt on land, it might turn to water, as its appearance suggested amphibious tendencies. Additionally, its jaw structure enabled it to catch fish. Although the oceans of the early Triassic were nearly devoid of life, small fish were present and served as secondary food for this predator. However, the strongest and largest marine reptiles of the time were the ichthyosaurs, characterized by their long, pointed snouts and bodies resembling dolphins. These creatures thrived in the Panthalassic Ocean, spreading widely. Many might find the early Triassic gloomy and unremarkable, but I see it as a second chance, an opportunity granted by God for life to recover. Despite the Great Dying being the worst event Earth had ever experienced, life continued. Remarkably, the early Triassic lasted only 5 million years, a short span compared to the subsequent late Triassic. Creatures like Lystrosaurus, Proterosuchus, and ichthyosaurs began their journey in the Triassic, displaying features that hinted at their evolutionary paths. For example, Lystrosaurus, a reptile resembling mammals but not classified as one. Proterosuchus, a predator closely related to crocodiles but not a crocodile itself. Ichthyosaurs, marine reptiles that might initially seem like extinct fish but were actually reptiles. The early Triassic showed us the identity of the era: survival and adaptation. By the Middle Triassic, a significant rift formed between the African and North American continents, allowing water to flow in and creating mountain ranges. This shift sparked diversification and revitalized marine ecosystems. Phytoplankton reappeared, improving ocean conditions, which led to the resurgence of ammonites and other marine life. During this period, new and distinct marine reptiles emerged, such as the Nothosaurs, whose name means false lizards. These creatures lived both on land and in water, much like modern seals. They had needle-like teeth perfect for catching fish. It's believed they were ancestors of the plesiosaurs, which appeared later. Nothosaurs had long tails and necks, with bodies ranging from 2 to 7 meters long. Unlike plesiosaurs, Nothosaurs preferred the surface more than deeper waters. Their remarkable adaptation allowed them to survive into the late Triassic, branching into 12 different species. If you think Nothosaurs are among the strangest marine reptiles, let me introduce you to an even stranger creature. Imagine its fossilized body, though its skull remains too obscure to fully reconstruct. Let me make it easier. This marine reptile fed exclusively on plankton and is closely related to plesiosaurs. One fossil shows rows of closely packed teeth, allowing us to visualize Adipodentatus more clearly. This creature had around 190 small teeth, earning its name, which translates to strange teeth. However, this wasn't enough to understand its jaw structure. Initially, we viewed its jaw as vertical, but later, research revealed its true horizontal structure. With further studies, we've concluded that Etopadentatus looked something like this. It stands out as one of the most peculiar marine reptiles I've ever encountered. Marine reptiles typically have long tails, and sometimes their necks account for a significant portion of their length. For example, Tanistropheus. Imagine it had a neck with 13 vertebrae, making its neck about 3 meters long, while the entire body measured only 5.5 meters. With such a body structure, it was challenging for Tanistropheus to thrive for long. Over time, its size began to shrink, and by the late Triassic period, Tanistropheus became extinct, having lived on Earth for around 20 million years. Some might think this is a long time, and it is indeed significant compared to human history. However, in comparison to creatures like ammonites, which survived for hundreds of millions of years, this is relatively short. The conditions of the Middle Triassic period seem to allow marine life to flourish to some extent. But did life on land experience any changes? One of the most significant events in the early Triassic, which peaked in the Middle Triassic, was the emergence of the apex predator Erythrosicus, the red crocodilian reptile. This creature reached a length of 5 meters, distinguished by a massive skull compared to its body, filled with sharp, deadly teeth. If I had only seen the skull fossil without the rest of the body, I might have mistaken it for a theropod dinosaur like Tyrannosaurus rex because of the resemblance. Interestingly, the red crocodile lived in the Middle Triassic, similar to how T. rex dominated the late Cretaceous. It possessed all the traits of a successful predator: large size, a jaw filled with teeth, and an environment that favored it. Despite forests appearing mid-Triassic, Postosuchus preferred hunting in desert-like areas, devoid of hiding spots. However, despite its dominance, it only survived for 5 million years, making way for other archosaurs to emerge. The life of the red crocodile reminds me of Shringosaurus, the horned lizard, a herbivorous creature that also survived for only 5 million years. If you're watching this video in the future and they've discovered that Shringosaurus looked different, that wouldn't be surprising because no complete skeleton of this horned lizard exists. From the specimens available, we know it was a herbivorous lizard that lived in herds, with relatively large sizes for Triassic creatures, measuring about 4 meters in body length. One of its most remarkable features was the presence of horns, a peculiar characteristic for a type of terrestrial reptile. Another noteworthy event of the Middle Triassic was the emergence of mammalian ancestors such as cynodonts, including Diadmodon. However, it's essential to clarify that these were not placental mammals like those we see today, but rather ancestors of modern mammals. Creatures like these were vastly different from the Triassic environment, as they weren't classified as reptiles. There's also evidence suggesting that Diadmodon had a light fur covering its body. Paleontologists debated whether it was herbivorous or carnivorous based on its teeth. Ultimately, they concluded it was omnivorous, feeding on small reptiles, insects, and plants. These creatures only lived during the Middle Triassic, yet they were more successful than the reptiles mentioned earlier, as they adopted survival strategies similar to Lystrosaurus by hiding in burrows. Their small sizes, often under 2 meters, provided ample hiding spots. As the Middle Triassic drew to a close, some strange creatures began to appear, such as Arizonosaurus, a lizard branching from archosaurs. It had a distinctive sail along its back, likely inherited from its Permian ancestors, resembling Lotosaurus, which had a more compact size and a smaller sail. These creatures were herbivorous and didn't last long in the era, going extinct by the late Triassic. In contrast, Longisquama lived through both the Middle and late Triassic. This creature is one of the strangest finds in paleontology, evident from the ridges along its back. If these ridges didn't exist, it would look like an ordinary small lizard. Fossils of Longisquama reveal strange structures. Some interpret them as ridges, while others see them as wings akin to dragonflies. The fossil evidence puzzled many scientists, leading to debates about whether it was a large insect. Given the low oxygen levels during the Triassic, the idea of massive insects is unlikely. Instead, scientists suggest it was a flying reptile, with the structures on the first fossil representing folded wings. This brings us to Chaerovipteryx, a gliding reptile with sail-like wings, considered one of the earliest known flying reptiles. However, there aren't many fossils of it, making it challenging to gather much information. In the end, the Middle Triassic was a period of recovery and biodiversity, showcasing mammalian ancestors, formidable predators, marine reptiles, and even early flying reptiles. This set the stage for the late Triassic, where dinosaurs and true mammals began to appear, and we'll see whether the strange forms of life that emerged during this era would disappear or persist. By the late Triassic, true diversity began to appear in the fossil record, with new types of plants, fish, and even tetrapods thriving. This was largely due to the breakup of the supercontinent Pangaea, a process that began in the late Triassic and continued until the continents took their current form during the Cretaceous period. This event allowed for the formation of new environments such as oceans, seas, lakes, mountains, and islands. When you compare the climate of Pangaea in the early Triassic to that of its later stages, the difference is significant. Additionally, the atmosphere was not like today's. Carbon dioxide levels were much higher, which could have caused a greenhouse effect. At that time, the climate started to become highly seasonal with cold winters and extremely hot summers. Even rainfall became seasonal, occurring mainly in coastal areas. This left much of Pangaea in a state of severe drought. Under these conditions, biodiversity began to take hold. Notably, during the Middle Triassic, reptiles were often described as strange, and with these gradual changes, the forms of reptiles began to evolve. This actually happened during the early late Triassic, where some very peculiar archosaurs appeared, such as Desmatosuchus, characterized by its scaly, armored body and side horns that were among its most notable features. It was one of the earliest creatures to develop horns. Another example is Pastosuchus, which looked like a project halfway between a dinosaur and a crocodile. Its name even translates to crocodile from the front. What's clear is that this creature was among the top predators of its time, reaching up to 4 meters in length. However, it wasn't the largest, as Silosuchus ranged between 3 to 10 meters long. Although it was herbivorous, it is considered one of the largest bipedal reptiles of the late Triassic. You might ask why so many creatures from this period have names ending in -suchus. The reason is that these creatures had a strong connection to crocodiles. Many of their names end with this suffix, derived from the Greek word for crocodile. For instance, the 3 creatures mentioned earlier are closely related to crocodiles and are part of the Pseudosuchia family, meaning false crocodiles. While they share similarities with crocodiles, they aren't directly related to modern ones. It's worth noting that the Pseudosuchian are distinct from the phytosaurs, which strongly resemble crocodiles in appearance and lifestyle. However, a key difference is that phytosaurs had slightly longer limbs compared to modern crocodiles. Interestingly, despite their striking resemblance to crocodiles, Pseudosuchians are more closely related to crocodiles than phytosaurs. Now, does that mean any creature with suchus in its name is related to crocodiles? Not necessarily. Take Lagosuchus, for example, one of the smallest reptiles that lived in the late Triassic, which has a closer relationship to dinosaurs than to crocodiles. As I mentioned, the suffix isuchus just indicates a crocodile-like feature or lineage within the larger Archosauria group, which includes crocodiles, birds, and dinosaurs. Speaking of classifications, let's consider a peculiar reptile that puzzled scientists for years. If I showed you an image of it and asked you to describe it, you might say, a lizard resembling a chameleon but with a bird-like beak. You might even notice its tail ending in sharp, bony structures. This is the Drepanosaurus, a creature so unique that it initially stumped researchers. While its skull resembled that of birds, it clearly didn't belong to the lineage leading to modern birds since birds didn't exist yet. Instead, it is classified in its own family, the Drepanosauridae. Drepanosaurs had specialized features such as climbing claws and a tail adapted for gripping and balancing on branches. They also varied widely in tail shape and length. Some had short tails while others had long ones with spiked tips. This leads us to an important question. Why were most Triassic creatures so strange? Think about it. Take a moment to reflect. The answer ties back to something I mentioned earlier. Let's save the detailed answer for later, but keep pondering it as we move forward. Now, when did dinosaurs first appear? The first thing that might come to mind when I say Saurischians is large herbivorous dinosaurs like Brachiosaurus or Argentinosaurus. But early dinosaurs were nothing like that. Take Eoraptor. It was much smaller, measuring just 1.5 meters in length, and its fossil evidence shows a mix of teeth types, suggesting it was omnivorous. Despite its name and association with Dromaeosauridae, famous for the velociraptor of the Cretaceous, Eoraptor was distinct from later theropods. It walked on 2 legs, was relatively small, and displayed a more generalized diet. Interestingly, scientists once considered Herrerasaurus, another early dinosaur, to be the oldest. Its fossils date back 400,000 years before Eoraptor. Herrerasaurus belonged to the Herrerasauridae, an early branch of theropods. It was larger, reaching up to 6 meters in length and weighing over 300 kilograms. So why do scientists still regard Eoraptor as the oldest dinosaur, even though Herrerasaurus predates it? In fact, this is due to two reasons. The first is that Herrerasaurus did not live for a long time during the late Triassic, despite its diversity. The second reason is that it was classified in its own separate family, distinct from the theropod family. Focus with me because this part is tricky. Dinosaurs are divided into two main groups, Saurischians and Ornithischians. Saurischians branched out into many divisions. We only mentioned the theropod family because the other species were largely recessive or less dominant. The Herrerasaurids were different and evolved separately from theropod lineage, which later produced most of the predatory dinosaurs. For this reason, scientists considered Eoraptor to be one of the earliest dinosaurs. One might assume that all early dinosaurs in the Triassic period were small in size. You're telling me the earliest dinosaur was 1.5 meters long? This was the prevailing condition at that time. Most early dinosaurs were bipedal and small in size. But after the emergence of Eoraptor, the larger Plateosaurus appeared, which some estimates suggest could reach up to 10 meters in length. Plant-eating dinosaurs began to dominate in the late Triassic, replacing dicynodonts and pseudomammals. However, Plateosaurus can't be considered a true sauropod because it was still bipedal. Then came Melanorosaurus, which appeared after Plateosaurus and is considered a true sauropod because it walked on all fours. Although research indicates that Melanorosaurus was smaller than Plateosaurus, the latter is considered a primitive sauropod, while the former is regarded as a true sauropod due to its quadrupedal nature. So we've now learned when dinosaurs appeared, followed the fossil record, and observed their evolutionary changes. But we've only discussed herbivorous dinosaurs. The first one was omnivorous. Later, we talked about early sauropods and eventually true sauropods. We even mentioned a predator that lived for a short time and then disappeared. Now, I want to know about the beginnings of the theropods. The earliest theropods in the Triassic are attributed to the fossils of Colophysis, a predatory dinosaur that lived about 215 million years ago. It was 3 meters long, highly agile, and widespread across Pangaea. Despite its small size, it was one of the deadliest predators in the late Triassic. This little predator is considered the ancestor of the giant predatory dinosaurs that would appear in later periods. To understand more about the origins of dinosaurs, we need to discuss dinosauriforms, the group believed to link ancient archosaurs to true dinosaurs. Dinosauriforms, translating to dinosaur-like forms, were primitive creatures that lived before the dinosaurs. They were generally small, quadrupedal, and herbivorous. One of the most famous is Silosaurus, whose fossils were discovered in Poland. This creature was 2 meters long and exclusively herbivorous, resembling Lagosuchus, which we discussed earlier. Unlike their portrayal in films that depict these creatures as fierce predators, such as in the movie 65, which showed Lagosuchus as a top predator, most dinosauriforms were small in size and not at the top of the food chain during the Triassic. To clarify, in the early late Triassic, dinosauriforms diversified, leading to the emergence of true dinosaurs. By the late Triassic, true sauropods dinosaurs had emerged alongside predators. Although they weren't as large as their descendants, they marked the beginning of a new era. This concludes our summary of early dinosaurs. Now we'll end the video. Oh wait, we haven't discussed the emergence of pterosaurs or mammals, nor explained how the Triassic period ended. Don't worry, we'll cover all of this. In the Pangaea Desert, a very small creature measuring about 2 centimeters was searching for tiny insects to eat. This creature was called Scleromochlus, and it was among the weakest organisms that appeared in the late Triassic. Interestingly, it possessed a skull and skeleton very similar to pterosaurs. The only difference was that pterosaurs had wings for flight, while Scleromochlus didn't have anything like that. However, the significant similarity in their skeletons led scientists to speculate that this creature might be a precursor to pterosaurs. As mentioned earlier in the video, the Triassic period is characterized by many creatures belonging to the archosaur group. Archosaurs are divided into 3 main branches: crocodiles, dinosaurs, and pterosaurs. Contrary to popular belief that pterosaurs are flying dinosaurs, they are actually a separate group, but closely related to dinosaurs. Around 220 million years ago, pterosaurs first appeared in the fossil record. According to current fossils, Eudomorphodon was one of the first pterosaurs to emerge. This event was one of the most significant in the Triassic period because before that, there were very few flying creatures, most of which were small. But Eudomorphodon stood out with wingspans reaching up to 100 centimeters. Over time, their sizes began to increase, with some species reaching up to 1.5 meters in length. Interestingly, while pterosaurs could fly, they also walked on land like Scleromochlus, prompting scientists to ask a crucial question: how did wings evolve? Many theories have been proposed, the most famous being that Scleromochlus leaped long distances to catch insects. Over time, small wing-like structures developed to enhance its jumping distance, eventually evolving into full wings. However, I personally am not entirely convinced by this theory. Yes, there is a significant similarity between Scleromochlus and pterosaurs, but to confirm this theory, we need to find a fossil that connects the two. So far, no such fossil has been discovered. Thus, the question of where pterosaur wings came from remains unanswered. However, it is certain that these creatures would dominate the skies for millions of years. Although they started with small sizes, future species in the Cretaceous period were enormous. For instance, if you've never heard of Quetzalcoatlus, you wouldn't imagine that these creatures would have a significant role in the future. This pterosaur had a wingspan exceeding 10 meters, making it a true giant. As new creatures emerged, others went extinct, such as the Dicynodonts. While many species disappeared, the largest and last of the Dicynodonts appeared, known as Lisovizia. This fascinating creature resembled a modern hippopotamus in body shape and had the size of an elephant, weighing around 6 tons and measuring about 4.5 meters in length. It was the last of the herbivorous Dicynodonts. As mentioned earlier, these creatures are considered reptile-like mammals, but not true mammals. Interestingly, in the late Triassic, the first mammals finally appeared, which would later evolve into Jurassic mammals. These early mammals were very small, about 10 centimeters in size, resembling modern mice. This marked a significant shift in the ecosystem. One fossil in particular dates back to Morganucodon, which is small in size and has mammalian teeth, as seen in its jaw fossil. Now, you might wonder about the marine life in the late Triassic. As usual, there were strange creatures that appeared in the early stages of the late Triassic, such as Henodus, a marine reptile similar to modern turtles, but looking like its shell had been flattened. However, towards the end of the late Triassic, marine life began to decline. Many creatures disappeared, and even those that survived became fewer in number. In contrast, ammonites and ichthyosaurs continued until the Jurassic and Cretaceous periods. This brings us to the question, why were Triassic creatures so strange? Remember how the Triassic period started, with the Great Dying Extinction. This event wiped out most Permian creatures. After this extinction, the planet had very few creatures, most of which were therapsids, whose forms appeared strange compared to dinosaurs. To adapt, these creatures grew larger to defend themselves against predatory archosaurs. With continuous changes during the Triassic period, the forms of creatures evolved gradually. In fact, creatures of the early Triassic differed from those in the middle Triassic and those in the late Triassic, illustrating the impact of the Permian extinction and continental drift events. Towards the end of the period, earthquakes and volcanic activity increased significantly due to continental movements. This released greenhouse gases, leading to global warming. This event, known as the Triassic-Jurassic extinction, was the fourth mass extinction on Earth. Although less severe than the Permian extinction, it wiped out many creatures including Pseudosuchia, Dicynodonts, and early archosaurs. As dinosaurs were small at the time, they managed to survive due to their lower food and oxygen consumption. This allowed dinosaurs to rise and dominate the Earth, ruling over other creatures. As you can see, the Triassic period was marked by two major events, in addition to smaller extinctions and various environmental changes. All these factors made the Triassic period unique with its fascinating and strange creatures, making it one of the most intriguing and exciting periods. If you enjoyed this episode, don't forget to hit the like button, as it motivates me to continue. Thank you so much for your time. See you in another prehistoric journey.